Hi guys, today we're going to talk about the classification of matter. We're going to start off with the basics of pure substances. These are substances that have nothing in them but one type of thing. So they're not a mixture. We'll talk about them in a little bit. Our first pure substance is a pure element. Elements are those things that we find on the periodic table of elements. Some popular ones that we know of are gold and silver, tin, carbon, and oxygen. So if you have a tank of oxygen, maybe you've seen someone walking around with a tank of oxygen with the tube, or someone in a hospital, that tank has pure oxygen in it. And oxygen is an element. What it means to be an element is that there's only one kind of atom present, and every atom present is the same. Now, elements cannot be separated by physical or chemical means. The only way we can change an oxygen atom into something else is to split the nucleus, and that's nuclear chemistry, and we'll talk about that in a different video. So elements, those atoms can't be changed, and when we have them in a container like a pure bar of gold or a pure bar of silver or a tank of oxygen, there's nothing there but those atoms of that element. We can also have pure substances that are made out of compounds, like water, a glass of pure water, nothing else in it. That's kind of hard to find because we know even our tap water has other things in it, like fluoride. So a glass of water is going to have nothing but water in it. So it's pure, but it's a compound, and that means that we have hydrogen atoms bonded to oxygen atoms. As we can see here, we have two hydrogen atoms bonded to an oxygen atom, and that's one water molecule. And a glass of water has millions of water molecules in it. Now, we can separate that hydrogen off that oxygen, but it takes a whole lot of energy, and that would require a chemical reaction to separate those two. More on that in a little bit. So aside from a pure substance, we also have mixtures, which is a combination of two or more pure substances brought together, but they basically keep their same identity. They don't change, they don't bond to each other like that. Those two hydrogen and that one oxygen and water are bonded together. In a mixture, things are just hanging out together. And we can think of a lot of things that we mix together, like chocolate syrup and milk, sugar in tea or coffee, salt in water. Even when you cut up all the vegetables to put into a salad, you mix them together. They're not bonding to each other. They're staying separate, but they're mixing together. So when we have things mixed together, we can physically separate them, right? So going back to that salad, if I don't like black olives, I can pick all the black olives out of that salad, and the rest of the salad things still stay the same, and the black olives are still olives. But if I have things that are chemically bonded together, like water, I'm going to have to use a chemical process to separate those hydrogens and oxygens from each other, and they are no longer water. They're going to be hydrogen gas and oxygen gas. So when we have things mixed together, they're just physically mixed together. They're not bonded to each other. You like that? That was pretty strong there. All right, we have two types of mixtures. We have a homogeneous mixture, which means that everything is the same throughout. It's very uniform. Homo literally means the same. And there's no visibly different parts. So when we look at a glass of milk, it's all the same. When we look at chocolate ice cream looks the same completely throughout. So even if we were to look at something like chocolate ice cream with chocolate chips in it, the chips are different than the chocolate ice cream, but they're throughout the whole ice cream. They're not just in one place. Every wonderful spoonful of chocolate chip ice cream, we're gonna hit a chocolate chip. So you see some examples here. A glass of water is a homogeneous mixture. An unopened can of soda. Soda has sugar and salt and carbon dioxide gas. Chicken broth has a whole bunch of things in it. Those are homogeneous. Then we also have a heterogeneous mixture, and that has one or more phase, meaning that they're not uniform. The mixture has different layers to it, usually very visibly different, like oil and water together. Or if we put too much sugar in iced tea and the sugar all goes to the bottom of the glass of iced tea. An open can of soda, so we've popped the top and all the fizzing's happening, that's actually heterogeneous because the carbon dioxide gas starts to come out of the liquid, and so it's separating into different layers that we can see as those bubbles. And then there's that salad example again.